In this lecture, we will see how to design a circuit diagram, layout, and a new component to be created. To implement any circuit, we have a choice of choosing the components. But then components have different packages and every package has different dimensions. Second, the pin number and pin functionality is different for different packages. So if you refer any data sheet, say for example Max 232 IC, where as you can see it is a 16 pin IC, but however there are different packages are available. In this case, say for example VCC is pin number 16, ground is pin number 15. But if you look at the package, the packages are PDIP package is available, SOIC package is available, and an SOIC again DW package or SOPNS package is available. So though functionality wise we are looking for a Max 232 IC, maybe for converting TTL into RS232 signals, but IC point of view, the pin functions are not same for package to package. So whenever we design the circuit diagram by using some software, so one has to remember the component and then one should remember the package. If the package is not available, then you need to create the package on your own. This will happen because time to time new packages will be coming in the market and that package or the component might not be there in the software. So usually every data sheet, at the end of the data sheet, they provide the mechanical dimensions. Say for example, if you look at plastic dual inline package, it is given the dimensions. Say you can see the dimensions. The dimensions are either they are inches, or in bracket the dimensions are in millimeters. Say for example, if the distance between one pin to other pin is 0.1 inches or 2.54 millimeters. So by knowing the uh, the size of the IC and distance between the pins and size of the pin, that is the pad, and the possibility of some tolerance between the whether it is a 14 pin or 16 pin or 18 package, so then these things has to be implemented in the design software. Similarly, if you see the plastic small outline or SOIC package, where th this has pads, it doesn't have pins, they are flat pads. So you don't need to have a hole here, it is a surface mounted device. So again you can see the distance between one pad to other pad is 0.050 inches or 1.27 millimeters, and the width of the pad is 0.020 inches or 0.51 millimeters. So looking at these dimensions, either if they are there you should choose a correct package. If it is not there, then one should know how to create a new component in the software. So for this tutorial we are using a software which is Eagle software. So whenever you use this software, there are three things. One, creation of a circuit diagram. Second, creation of a layout. Third, creation of a gerber files. These are the three steps for any project to be or product to be implemented. So first let us see how to create a circuit diagram. So go to File, New, then Schematic. When you open the schematic diagram, as you can see, the uh, this area is called workspace, where as you can see the coordinates are indicated, which are in inches. That is called grid size. As I am moving x-axis, as you can see the x coordinates are changing. If I am moving in y-axis, the y coordinates are moving. So that is the placement of the component. If you want to change the view, you can go to view, then in grid, instead of inches, you can go for millimeters or any other uh, units, or else you can change the size of the grid and alternate grid, so that if you want to minutely adjust the placement, then the step size you can reduce, and the dots or lines whatever you want, if you say on, then you will notice it will display the lines. But if you say dots, then instead of lines it will display the dots on the screen. If you doesn't want to view these grids, then you say off. Okay, then the workspace will be plain. So this is the about the workspace. You can use the mouse, uh, the scroll bar to zoom in and zoom out, and or else you have the tools to zoom in and zoom out your workspace. Okay, so if you want to first select the components, where the components are there, the components are there in the left side screen. There is a tool called add. So this button will select the libraries where you can choose the components from this library. And if the library is not there, then you go to the library, and then you can say use. If you have any new library to be added to the workspace, you can say use. Then you can see in the folder program files, Eagle in LBR folder, all the libraries are there. Whenever you have a new library, then you must select that library from here, and then you will have to say open, then it will automatically come into your workspace. Okay, so let us use the libraries. Then you can say add. It will take some time to load all the libraries into your workspace, because it depends on the size of the computer's memory to load all the libraries into the memory space. So as you can see on the screen, where whatever is the libraries you have selected to use, those libraries are available here. So if you just expand your, though we have selected the 7400 IC, however, as you can see, the some suffix or prefix is changing, like C, D, F, K, N, A, S, H, C, and all. And similarly, if you look at the package, so this is SO14, where you can see this is the schematic, but however, if you see the layout, this is called SO package, SO14 package, which is a surface mounted device, where pads are there, but there is no holes. Similarly, if I select some LC20 package, where the pads are there on all four sides, and again this is a surface mounted device, there are no holes. But what you can notice is schematic diagram is same for both the ICs. Third is DIL package. Here now pads has holes. The color is in green, means this pad is there on top side as well as bottom side, and there is a hole is there, but schematic is same. So when, for example, let us select this component. So when you place the component, we don't know what package it is, because that will be reflected on the other side. So while choosing the components, one has to carefully choose the package also. So when I place this component, as it shows that first gate in IC1 A is selected, 1 2 3. If I click one more side left button of the mouse, then B, IC1B is placed, that is pin number 4 5 6. If I select left button, then third gate is placed. If I again select fourth button, now last gate is placed. Now if I want to escape, then press escape, then you can say cancel, then it will leave that. So this NAND gate 7400 has gate 1, gate 2, gate 3 and gate 4, that is a D gate. But nowhere pin number 7 and 14 is shown here. So in some ICs, some of the pins are not shown. So before you finalize the circuit diagram, make sure all the important pins are there in your workspace. So if you don't take pin number 7 and 14, this IC won't work. So go to the tools. There is a invoke tool is there. Select that and click on this plus symbol. Wherever that IC's plus symbol is there, click on that left button. Then as it shows that you have already consumed A, B, C, D parts of that IC, but you have not selected the power signal. So if I click on that, say OK, now you can see when the power signal is available in your workspace, where 7 is ground and 14 is VCC. If you do not want to select some of the gates, it is no problem, but if you do not select the power, then IC won't work. Say for example, I'm not interested in fourth gate. You can go here, you can delete option, you can select and delete this. Now this IC will still work because supply is there. So choose the power supply of all the ICs in your workspace. Now how to join them? When you move the cursor's scroll bar, it will zoom in and zoom out. So through scroll you can zoom the workspace. If you want to join, say for example pin number 3 to pin number 5, you can choose here the wire tool, and then you can left mouse left button, you can click on that, then it will start the wire, and again click the mouse left button twice on the destination so that it will leave that wire. If you click only once, the wire will be still continued, but if you click twice, then it will end that, or else you can press the escape button. Okay, so this is how you can join the gates by using wire. So that is how you can join them. So let me take some more components, like say for example I want to select some microcontroller. So as you can see from ATML library, so many microcontrollers are there. So let us say 89C51 DIL package 40 pin microcontroller. So if I place this, now as it can show that it is a 40 pin IC, then if you again go for invoke and click on this, it says that no other pins are left, all the pins are there on this IC. So as you can see, ground is there, VCC is there, all the pins are mentioned here, all 40 pins are mentioned here. Now if I want to connect, say for example join this pin here, so if I double click it, it will leave that. But instead of joining the lines like this, right, if I want to, if you keep on joining the lines of all the 40 pins, then this entire area will be filled with wires, which will be a big mesh. So instead of that, I will there is another method to join. Say for example, I want to join pin number 4 to pin number 4. So what you do is start from here. Just draw a small wire and leave it. Similarly, start from the destination a small wire and leave it. Now this pin, if you want to join to this pin, let us give the label to the wire. So there is a name here, name tool. So select name. Then I will click on this wire. Now it says that right now NS5 is there. So $5 is there. I will give some name. Let us say A0 is the name I had given. So this name I had changed. But since I want to join this wire to this point, the same name here in the instead of $4, I'll give the same name A0. Okay. So now it says that do you want to join A0 with this old name? Say yes. Okay. Now though physically it is not visible, but logically this pin is connected to this pin. So how will you come to know that it is connected? There are two methods. One, you can go to show. There is a show and you can select this wire. Then if you selected this wire but this is highlighted, only this and this is highlighted, that indicates that these two pins are connected. This is one method. Second method is there is a label here, tool label. So select this label and select on this wire. Now it says it is A0. Again click once again, then the label is placed here A0. Select the other wire also, select it and place it. Now it says that this is also A0, this is also A0. That means both the lines are connected. So instead of using physical wires, one can join these pins by using logically by naming them. Okay, so this is one way to join them. Now if you want to join common points, let us say this ground and this ground you want to join, there is a label. In the library, there is a library called supply 1 and supply 2. Let us see supply 1. In supply 1 you can see various labels are there. First you can use any of them, whichever is suitable to you. Let us say ground symbol I am using. Okay, so now I will place this symbol to this ground. Now the same symbol I will place it here also. So it means this ground and this ground are connected together because the name is same. Or I will slightly use the move command and just drag it slightly so that the net name is visible. Okay, now if I highlight this by show command, right now this is highlighted. That means this ground and this ground is same. Even if you try to see the name of this, it says this is a ground and now this is also ground. So that means you can use some common labels, symbols to join them. Similarly, I want to connect this VCC and this VCC together. So I don't need to physically draw the lines. I can use again the library. Say if it is a 5 volts, then I will use the symbol 5 volt symbol. So I will place it here. The same label, I will use it here. So slightly move it. Okay. Okay. Now if I say show command, now you can see this is highlighted and this is highlighted. So that means both the VCs are connected together. So whenever you have some common pins like VCC ground, you can use the symbols to join them. So let us see some more components. For example, you require a crystal here, so you can go to the library. One should spend at least maybe in half an hour to know about all the libraries which symbol is where. So crystal is a library, as it's you can see crystal library. Now when you choose these crystals, now see this is a 3-pin crystal, and this is again 3-pin, so the dimensions are different. So there are different packages are there. I will go to crystal library. Within the crystal library, now I say for example, if you see this is a surface mounted device, so these are different crystals, right? I will choose this crystal what is called HC18UV, which is which is used in the circuits, which is vertically mounted. Dimensions is 5 mm is the distance between the pads. So that is important. So you can press the right button of the mouse to change the direction of the component. You can press here, and now I will use the wire to join the crystal. So whenever you join it, double click. If you do not want inclination, then choose the right angle from here. Then you will get right angle. So double click to leave that. Similarly, if you want capacitors to be connected, then in the library there is a capacitor. There is a capacitor folder is there. So you can use either bipolar capacitors or unipolar capacitors. So the difference is these capacitors, they doesn't show the polarity. So these are usually the capacitors without polarity or ceramic capacitors. But if you see these capacitors, these are capacitors with body mounted, that is there's a third pin is provided here, but again they doesn't have polarity. But if you want a capacitors which shows polarity, like say more than 1 microfarad, then you can go to there is a library called a resistor. But in this again, in this resistor, he has provided various packages, even capacitors. So as you can see, capacitors where with polarity is there. Say for example, if I use capacitor European Union, so these are surface mounted capacitors where again dimensions are different depending on the capacitor value. So these doesn't have polarity, but if you want capacitors with polarity, polarized, see polarized. So if you use the polarized capacitors, now you can see there is a plus symbol is there in the symbol, and these are all SMD. But not only in the symbol, even on the footprint also you will get a plus symbol wherever positive lead is there. So depending on the capacitor value, you can choose the distance between the pads and the size of the pads, and advantage it will also show the polarity of the capacitor. So while mounting it will be easy if you have a polarized capacitor, so that which is positive and which is negative will be indicated on the PCB itself. So if you want non-polarized capacitors like less than 1 microfarad, then you can use this package called disk capacitors. Okay, so I will connect a capacitor here. We'll connect a capacitor here. So other end of the capacitor need to be connected to ground. So if I want a ground to be placed here, there is a copy command. I will use copy command to place the ground here. Again I will copy the ground here, and so there is a move if you want to move any component. Okay, so if you want to move all these components some other place, then say you can choose this move command. Then there is a group. You select the left click of the mouse, you select it, and by using left click of the mouse, mark the area and then leave it. Now this area is highlighted. Now press the right button of the mouse, then you can see move group is there. Press again left button of the mouse, and wherever you want to move those components, you can move it. This is applicable to delete also. If you want to delete any area, then select the delete group first, delete tool, then select the group button, then you can mark it, and if you right click, it says that do you want to delete the group. So you can delete the entire this thing, or you can escape to cancel that option. Okay. So once you place the components, now you can verify whether the circuit is correctly connected or not. The we will see some more components, like say for example, if you want some resistors, you can choose the resistors where these are there. Again, when you choose the resistors can be selected based on the wattage, whether it's a half watt, quarter watt, 1 watt accordingly. Or if you want surface mounted resistors, then you can see 1206, 0805, 0603 is the size of the resistors. For example, 0603 means 2 mm is the distance between the pads. 1206 means is a slightly larger in terms of the pad. So one can choose which capacitor you want. If I choose this and if I place it here, this resistor, then in schematic it doesn't indicate whether it is a surface mounted device or a plated through hole. But in layout we will see that will be the package will be shown there. So I will select a resistor which is, now you will find there is no difference between schematic diagrams. So how to give the values to the components? So there is a button called value. So if you choose this and if you choose on the component, say for this capacitor I want to give some value. So if you left click the mouse button, for example 33 picofarad is the value I want to give. So now it says that this capacitor value is 33 picofarad. If this resistor I want to give some value, left click on it, let us say 10k. So if you select it, this value is 10k. You can copy the components, but never copy the wires. While joining, you never copy the wires. The reason is, if you copy the wires, then the same name will appear here, then this and this will be shorted. Let me delete this. Say for example, there is a A0 wire. I will copy this, and if I place it to this point, now you think that a new line is drawn here, but actually if I say show command, now see if I click this, even this is highlighted, this is highlighted. That means this and this and this is shorted. So that is why never copy the lines. You always draw the new lines. While drawing the lines also, for example, by any chance if you want need to cross the line, you can cross it, no problem. Say for example, I will join here. So don't think that it is shorted. If you want to verify, you click on the show command, you click on that. Then it says that only this line is highlighted, this is not highlighted. Or else you can use the move command, then you can move this line as it shows that it is not shorted. But by mistake, say for example, I will draw this line again. While drawing the line, by mistake, if you click here in between where there is a line is crossing, now it will show the error also that you are trying to short it. By mistake, if you say OK and if you continue it, now in this case, actually, physically it is not shown, but actually it is shorted. See, if I say show command here, now you can see this and this is shorted. or by move command also you will notice both are shorted. So while joining the wires, wherever there is a cross is there, never click on that, it will short the other pins. So these are some of the commands. If you want to change but any point of time any of the components, then you can use this change. There is a change is there, so you can change maybe the width, maybe font and display types and all, the values and all. So by using that also directly you can change. For example, package, if you want to change, if you click on it, right now so and so package is used, but if you try to select some other component, then in the back end the package is changed automatically. So change you can at any point of time without deleting the component. You can change the package or font and so on. Whenever you want to identify the component from which library it has come from, then there is a info command is there. So if you select the info and then if you select the component, then it shows the complete information from where that component is taken from which library it is, what package it is, what are the dimensions, everything will be shown here. So that is about the information. So once the circuit is designed, it is immaterial where the components are placed. You can place wherever you want, because this doesn't represent the placement of the components on the PCB. It is just a logical representation of the circuit diagram. Actual placement you will have to do it on the board side. So you can save the your workspace, say save, then it will give SCH is the schematic diagram. So you can give some name to your circuit. By default now it is saving in program files eagle folder. I will give some 123 is the name of my schematic diagram. So this completes the design of the circuit diagram. Once you save it, now if there any errors are there in the circuit diagram, then as you can see there is a tool called ERC, error check. If you select this, then you can see on the right side it will show how many unconnected pins are there and how many pins which are some missing junctions or conflicts are there. If you click on that error, it will show, for example, it says that this particular pin is not connected. So it is up to us whether that error is a valid error or whether we can continue with that error. But if you select this, this says that there is a missing junction is there. So such type of things you just verify these warnings, whether those are acceptable warnings or you can say approve, then all these warnings is accepted. So that is how at least just a cross verification before finalization of the circuit diagram. If you want to place any comments on your schematic diagram, there is a text window is there, so you can select text. For example, this you can talk about what is the functionality of your circuit diagram or anything which you want to remember. Let us see if I type. So if I want to say microcontroller, then you place wherever you want. So that text will be there. So this will complete the schematic diagram and error verification. Now let us go for designing the board. So to design your PCB, there is a on top of your screen there is a tool called generate or switch to board side. So if you select on this, now it's saying do you want to save it, and yes. Now if you expand this, you will see whatever you have components selected on the circuit diagram, they are reflecting on the board side. This is your workspace where you will have to move all these components here. So you can move them all of them together or one by one, like say I will move one component at a time. So that way also you can move it, or you can move all the components in one stroke. Let's say I will mark the area and right click, move group. Now you can right click again to change the direction and place the components. Okay, now while placing the components, where you should look which component where it is connected. For example, if I see this resistor is connected here. So somewhere closer to that, that resistor should be placed. So similarly, this capacitor is related to this component. This capacitor should be no more closer to this particular pin. So the circuit, while designing, yeah, on the circuit diagram side, it is immaterial where they are placed. But while placing the components on the board side, it is very very important, because it depends on the application where components should be placed, where connector should be placed, where power supply should be placed, which I have discussed in the part 1 of this video lecture. So this is your border or cutting edges. So these cutting edges, you should move it. So I will select a move to whatever is the size of the PCB you want. So this will decide the size of the PCB. So you should reduce to as small as possible, so that this area will decide how much size your PCB is going to be. Again, the grid indicates in inches. You can place the cursor to measure the dimensions of your PCB. Okay, so now this is, let us say, approximately the dimensions of your PCB. How to draw the layout? Right now, these are logically connected, these wires, not the layout. So we'll have to make a layout now. So for layout, on the left side of the screen, you can see there is a tool called root. So you can select a root. When I select this root command, now you can see first of all the layers are indicated. If you see the layers can be top side, layer can be bottom side. So I am selecting bottom side. Now you can see what is the width of the track you want. At least I suggest a minimum 24 mils you should select. Then what kind of pads you want, but right now we are not putting any pads. So, and I will start now routing. If I start from here, now you see this width is approximately 24 mils. So whenever I change the direction, you can see it is changing right angle. But in layout, never use right angle, which will, there is a possibility of hair cracks. So use slightly inclination, wire bend style. So now if I change, see this side, then it will bend that. So now this is, so this color is in blue. That means the size of the side of the PCB is bottom side. So now this will complete my starting point and ending point of my copper track. Similarly, I will again, as you can see, I selected route. Route means now I am routing, manual routing. Now you can see again I can design manually my own layout. Okay. Now if I want to change the width anytime, for example, for power supply, I want to increase. So 0.05 mils if I want, I can choose. So if I want to increase, say for example, ground. So ground slightly thicker wire I want to use, I can do that. But now there is no space for me. Okay. Now see, this is a ground line, which should be at least thrice than your VCC line. If you want to pass the wires, choose the 24 mils. So if you want to pass the wires between the pads, you can do that. So as you can see, you can pass a wire between the pads. So this is how one can do the manual routing. If you have any corrections to be made, then go to the tool called rip up. Select the rip up. If I select on the track, now this is again cancelled. It comes back to wire form. As you can see, now it is again back to normal. Again you can route it. If you want to increase the thickness, then you can increase the thickness. Now I am routing it back. So this is not shorted because this pad is red color. That means this pad is there on the top side of the PCB, and this blue wire is there on the bottom side of the PCB. There is no short circuit here. But this track should not cross these green pads because the holes are there on top side, hole heads are there on the bottom side of the PCB. If you want to change the width of the line without deleting them, then you can go to tool called change. Then what do you want to change? For example, if you want to change the width, then currently it is 0.05. For example, I want to reduce it to 0.016. Then where you want to apply for that? I will click here. Now see I can change the width without deleting and rerouting the track. So change is you can anytime apply to those components. The once you have done manual, then second is you want to use auto routing facilities there in this software where all the wires are joined automatically by the software. So for that, first of all, if you want to do auto routing, then you should select what is the thickness of the wire while joining auto routing. So go to edit, then you can see there is a design rules. In design rules, there is a option called sizing. Now it is asking what is the thickness of the track you want to do while doing the auto routing. So you are saying minimum width, for example 0.254 mm if you are selected, then while joining it will use this thickness. Then you say apply, whatever you want, say apply, then OK. Now if I go to tools and they say auto router, now you can see how many layers are there for designing the PCBs. The layers are total 16 layers you can go for designing the PCB. If you want, say for example only single sided PCB, then switch off even the top layer, say not applicable. Now see all the layers are not applicable, only bottom layer I have selected as a horizontal line. Now round the grid routing, while routing grid size you can select only 5. Okay, and the shape of the grid, routing grid round shape you want. Okay, so now if you say OK, you will notice now it will start joining the lines by using whatever is the thickness of the line you have selected in the edit design rules. You should always observe on the left side of the screen which shows that how many lines are joined. So it will try 4 times. After optimization or 4, it will indicate how many tracks are joined. Right now it is showing 92.9% it has finished. That means as you can see still one track is left, it is unable to join. That means your design is not completed. So this is the problem in auto routing. If the design is 100%, if it is not 100%, then you cannot accept the design because there is a possibility of some of the tracks are missing, so jumpers may come on the PCB. So you have to redo that. Redo means you want to say, let us say cancel some of the tracks. So how to cancel the tracks is either individually you can say rip up. So some of the tracks, if you want to redesign, then you can cancel them. Or if you want to cancel the entire layout, then go to edit, then go to rip up. Then there is a tool called go. Then it is asking rip up all signals, say yes. Now you can see now all the routed tracks are cancelled. It has come back to the original position. So since there is a possibility of some percentage of not routing, so you can replace the components maybe slightly better organized, so that next time it will be able to join all the lines. So you need to simplify the path so that it will find some space to join the tracks. So while designing, always let us have some manual routing for special signals like VCC, ground, or some clock signals, and use the auto routing facility to join the tracks automatically. So if you want to go for double sided PCB, for example, I will first select the tools, then auto router. So this time I am applying top side also. So now vertical lines are on top side, horizontal lines are on bottom side. So if I say OK, now this time you can see it is using two colors. Red is there on the bottom side, blue is there on the top side, and it says that 100% finished. That means all the wires are converted into tracks. So this is double sided PCB. Double sided PCB means all blue lines are there on top side, red lines are there on bottom side. If you want to individually see the tracks, then you can go to layers. Then for example, top layer I will switch it off. Then apply. If you say OK, now you see, then it doesn't show the top layer. It will show only bottom layer. If I switch out of bottom layer, then see now even both the layer tracks are not shown. If I switch it off the pads, now you see the pads are not visible. So like that individually, the values, for example, if I switch it off, then even values won't be there. So individually you can switch it off the layers whenever you want to take the printouts or whenever you want to make a reports. If you want to see all of them, switch them all, then it will show all the layers of your PCB. So once you design your circuit diagram, then you can draw the ground plane. Ground plane means now in your PCB there is some space is left, where this place we can use it for filling the ground. That means the remaining empty space should be used for filling. That is called polygon draw. So your ground should be as big as possible, so that it will have low impedance for the return currents. So I will draw a polygon. So select a polygon. When you select polygon, then it is asking what is the isolation you want. Isolation means between the pad and the polygon, do you want to leave some space? You must leave some space, otherwise it will be very closer, then soldering will be difficult. So in isolation, I will say, for example, at least 0.016. If I select it, then that means 0.016 mils distance will be there between the pad and the polygon. Now I am drawing the polygon. Top side I want to fill. So select top side, and now I am starting from here and mark the area where you want to fill it by ground. Okay, now close the polygon. Now that means this entire area will be filled with a copper material. But then you should give the name to that. So because this area you want to fill with ground, not just filling, you want to make it as a ground. So go to name and select on the polygon. So now it is asking what is the name of this polygon. So you should give the same name what you have used in the circuit diagram, that is ground, as a polygon name. If you say OK, now this name of the polygon is ground. So the name of the polygon we have to give it by using the name command. this name should be same as what you have given on the circuit side, where this ground name and this name of the polygon should be same. So once you draw the polygon, then you should say a rat's nest. Then you can see this entire space with slight isolation is filled with ground. So if you can see, for example, pin number 20 of the microcontroller is ground. So this is shorted with this ground. So if I highlight this pin, you can see the whole plane is highlighted. That means this is filled with ground. Similarly, if I want to fill the top side, then again select the polygon. This time instead of bottom side, select the top side and mark the area where you want to fill, how much space you want to fill with the ground. Close the polygon, give the name to the polygon, say same name, ground. Okay, now if I say rat's nest, you can see the top side is also filled and bottom side is also filled. If you want to give any title to your board, then there is a text window. You can give the title, let us say some sensor board. Now this title, in which side you want? Red means top side, blue means shoulder side, or if you select the values, then it will be silk screen, means white color. So I will select value so that it will be in white color silk screen form on top side. Okay. So now when the PCB manufacturer makes the PCB, you can see how many layers he will make: top, bottom, and pads, and the silk screen. For example, if I switch off the top side, bottom side, pads, and vias, now you will see only silk screen will be there, which will indicate the name of the components. While we'll switch off all the layers, so you can save it, your design, and if you want to give this PCB to the manufacturer, then this is not sufficient. You need to create the Gerber files. So those are the files where a manufacturer requires, because computer generated files is not schematic and board. It has to generate the Gerber files where a CNC machine can understand. So how to generate the Gerber files in Eagle? You can go to file, and there is a tool called CAM processor. Select the CAM processor. Now once the CAM processor is open, go to file, then again go to open, then there is a job. Open the job. You can see there is a CAM processor called Gerber 274x.cam. You select this and say open and say process job. Now you can see it has processed the Gerber files. Again go to file, open, job, this time epsilon.cam, open, say process job. Then this has generated the Gerber files. You can close it. Again go to file, then this time there is a run ULP script is there. In this script, you can select in the ULP directory, you can select the script called drill cfg.ulp. So this will create the drill information of the PCB you have designed. Say open. Now it says that do you want to generate the output file? Say OK. Now if you say OK, now say save. Now it has generated all the information which is required for feeding into a CNC machine. So these files are there in your computer program files in Eagle directory. They are stored. So these files are more than 7-8 files will be there. While designing the PCB, you can also place some pads, additional pads for mounting on the cabinet. Say for example, as you can see, there is a hole. So you can choose the diameter of the hole, right? And you can place on the corners so that these are the mounting holes, so that with the help of the screws you can mount this PCB on the cabinet of your project or the product. If you want to include existing files into the current project, you can also do that, like merging two circuits into one circuit. Go to the circuit side. If already designed circuit is there, then you can go to file and then you can say import Eagle drawing. So if you already designed some circuit is there, which is you want to merge it, you can merge that. Now you can see there is a another circuit which is merged. So this is your old circuit, this is your new circuit. So that means it also creates as a sheets. So that means now both the circuits are part of your project. So if you go to your board side, now you can see even this is your old design. Now this is your newly added circuit. So you can place the components and move them so that both the circuits are part of your project. So that is how this is the advantage of, even if you have already designed circuit diagram is there, that could be import into the existing new project. Okay, so how to create the image files? So to create a image of your circuit diagram, go to file, then export. Now you can create a image. So where you want to create the image, say for example if you want to create in documents, so new give the name of the image, say circuit 1. Save. Now do you want to create a color or a monochrome? If you select monochrome, it will create a monochrome, otherwise it will be a colored image. Similarly for this, which layer, for example I will switch off the top layer and bottom layer. Okay, now this I want to create an image of it. Go to file, then export image, then browse the same documents I want to create, board 1. So now this the image of this circuit diagram and layout is created. So in your documents you will find the circuit and board are the two images which are created. So if you see the same, you don't require any software now to open the image. Just you can use any browsers to read these images, and they can be part of your PPTs or project reports without using Eagle software. So that is how you can export. You can also export the list of the list of the components. Say for example, if I say part list, and if you say save in documents, now you will see the part list file is created. You open this with WordPad. Use only WordPad. Now it will show the list of the components which you have used in your circuit diagram, like name of the component, its value, its pin function, and so on. So similarly, while designing your circuit diagram, always try to put some headers, so that if you want to connect the external connectors, then there should be provision. For example, you have used VCC and ground, but how will you connect these pins to the power supply? So then go to the this thing. There is a library called pinhead. So in pinhead, you can see 2-pin connectors, 3-pin connectors, and so on. If you use a 2-pin connector, so there is a 2-pin connector. So I will copy the VCC symbol and copy the ground symbol. Okay. Now rename it as if it is a connector for supply. Okay. So now this 2-pin connector, you can use it for connecting some uh, wires or some SHS connector, so that it will be used for mounting the budge strip male, so that with the help of female connector you can connect it to the power supplies. Now let us look at one circuit diagram which is completely designed, where the layout is prepared. So this is the most popular circuit diagram where number of students are using in training programs. A Atmega 32 based microcontroller, where as you can see there is a crystal to biasing capacitor, the VCC and ground is connected. So if I highlight, say for example, my VCC line, you can see the same symbol is connected here, it is connected here, it is connected on the connectors. And now where this VCC is coming from, how this board is getting power supply. As you can see here, there is a regulated power supply, where the input is, we have provided on a 2-pin connector, where if I identify this component, it is called pin. From the pinhead library we have taken 2-pin connector. So by using external transformer, if step down transformer 12 volts AC, after rectifying, if you connect it here, then that DC 12 volts DC, like we are assuming as if you are connecting a 12 volts DC here, then this DC will be regulated by the 7805, where the output will be 5 volts DC. You can see there are two filter capacitors at the input as well as the output. Then this is the DC. If I highlight this DC, you can see this is the DC which is connected here, here to the power LED and to the connectors, LCD, everywhere. Now if you look at the connectors also, we have used this pin head like 8-pin connector, so that externally if you want to connect any circuits or components, you can connect it to these headers. And you can see these 3-pin headers, the same signals. One side we have connected VCC, other side we have connected ground, and the center pin, if you see the center pin, we are connected to ports of the microcontroller, so that you can give inputs to this controller. Then similarly, if you want to connect a LCD, you can see there is a 16-pin connector is there, where the pin number 1 is ground, 2 is VCC, third is contrast adjustment, and the microcontroller's data bus is connected, like say DB0 is connected here. So without using physically wires, where we have given the names, that means PB0 is connected to PB0 here. Though the microcontroller is connected with various LEDs and all, but still we have provided those pins on the connectors also, so that any external interfaces in future, if you want to connect any boards, you can connect it to these FRC connectors, flat ribbon cable connectors. So if you want to, for example, generate a reset signal to the microcontroller, you can see there is a switch where you can mount the switch here. There is a capacitor, resistor, so that when the switch is not pressed, this signal is connected to the ground with the help of this. When the switch is pressed, this pin is connected to the ground. When the switch is released, this pin is connected to the VCC with the help of this 10 kilo ohms resistor. So this signal is nothing but this signal of the reset of the microcontroller, which is active low. So how to program this microcontroller? So since we do not want to remove this controller every time from the board, so these programmable signals which are connected to this connector, what is called in-system programming. So there is a 10-pin connector where there is a programmer, what is called USB ASP programmer is available. You can connect it here. So whenever you are using some microcontroller based systems, you should equally worry about how to program the chip without removing from the target device. So in short, now this board takes care of first about the power supply design, so that if you connect a 9 volts or a 12 volts DC, the entire board will get the 5 volts after rectification. Then second, as far as the microcontroller is concerned, though we have connected to LEDs, LCDs and some switches, but still those signals we also brought it on the connectors, so that as and when expandability is required, you can do that. Third is how to program this chip. There should be a provision what is called in-system programming, so that nowadays this facility is available almost all controllers. So without removing this chip, still you can program it by connecting a connector. If you want to bring it some useful signals like 3-pin connectors, 4-pin connectors, Bluetooth, Zigbee, if you want to touch screen, if you want to connect it, you should always provide by using some uh, pin headers, which is there in the library of pinhead library. Since microcontroller cannot drive relays, so in the relays are some DC motors, so you must use ICs which can drive the DC motors. So microcontroller output is connected to this input like say PC4, PC5, PC6 and PC7, and in turn this IC like L293D will drive the motors. Similarly, if you want to connect a relay, it relay requires at least 100 milliamperes of current. So microcontroller pin is connected to the transistor. Transistor will drive the relay. So that is how you should always take care about the current uh, requirement of the devices which you are interfacing to the microcontrollers. Whenever you have high value capacitors more than 1 microfarad, they have polarity. So you should take care about the positive side and negative side of the capacitor. Similarly, the diodes. Diode also has a polarity. You should properly connect positive, that is anode and cathode side of the diode. Similarly, the LEDs. LED again has a polarity, so the anode should goes towards the VC side, cathode should goes to the ground side. So at least some of the components have polarity, so that should be properly taken care. Okay, so now let us see the how the board side looks like for this. Though we have placed the components at different places, but then if you see, look at the board, how perfectly this is organized. Say for example, if microcontroller is here, where LCD connector is here, so that if you mount the LCD, LCD will go towards the board. That means exactly it will you are going to mount on top of the microcontroller, so that you will going to save the space. The microcontroller IO lines we are brought it outside, so that if you want to connect any keyboard or any external ADC inputs, then you can connect it. Programming is done through the help of this box connector, so that there won't be any mistakes while connecting, because this there is a notch, so you cannot connect the connector in other direction. Similarly, you can see the power supply. Entire power supply is placed at one place, so that even this heat dissipating components, heat sink is outside. This white portion indicates that heat sink, so that means we want to place it outside, so that the aluminum plate won't come inside, it will go outside, so screw mounting and all can be taken care the outside the PCB. Every component has a direction. If you see this IC, there is a notch. This notch to the left side of the notch, that is this is the pin number 1. Similarly, there is a notch, this is pin number 1. There is a notch, this is pin number 1. So like that, even these connectors, you can see this is there is a one pin number 1 dash is indicated here. So this is pin number 1, this is pin number 1, this is pin number 1. So like that, almost like say capacitors, this is positive side. Diode, this is anode. There is a LED, this is anode. The diode, this is anode, and this is cathode. So almost all the most of the components have direction, except say for example resistor, there is no direction. In any direction you can mount it. Or some capacitors like this disk capacitors, they doesn't have direction, because they are a picofarad, so there is no direction for that. In any direction you can mount it. Crystal doesn't have direction. In any direction you can mount it and connect it. Switch, there is no polarity. In any way you can connect it. So some of the components are like resistors or low value capacitors doesn't have direction. Crystal doesn't have direction, you can mount it. So if you see the planning of this design, LCDs on one side, switches are on the other side, connectors are the extreme edges, power supply is on the other end. So and then the components which you are not going to remove, they are inside center of the PCB. So that is how you have to plan. Majorly, if you are planning to interface some external components, where you require some edge connectors. If it is going to be inside the box, then probably the planning will be something different. So this is what is placement of the components. Otherwise, if I switch on the tracks, then you will see how the tracks are connected. Now I will switch on, say for example, top layer and the bottom layer of the tracks. Now you can see, now some of the tracks are very thick. Say for example this, if I highlight this, see this track is thick. That is because this track is your the supply line, 12 volts supply line. So because whenever you want to connect a relay, so that the relay draws more than 100 milliamperes of current, we want to be very thick line. Similarly, if you see this track, this is ground line. See, wherever ground line is passing, it is thicker than any other signal lines. So entire PCB, wherever ground is there, it is we are use a thick line. So once you have done at least your VCC line and ground lines, thicker lines, then rest of the lines you can use auto routing, where we are not routed, it is taken care by the auto routing software. So these pads, if you see the small pads in between, I will switch on the pads. If I see the pads vias, right? Now if you see these pads we have not placed. The auto routing software on its own, it has placed the tracks and pads. The pads what we have created is which are coming along with the package itself, like these bigger pads, but the small pads which are also conducting, but the software has created, so that it will change the direction. Say for example, this line has come from bottom side, and you want to continue the track on the top side, so it will put a PTH pad and it will continue on the top side. Now though this track is crossing from the it is crossing the horizontal line, but still this is not short circuited, because this blue line is there on the bottom side, red line is there on the top side. So that is how, while designing the PCB, first of all placement of the components, second is at least the power supply lines and ground lines has to be routed manually. Then at least any critical signals are there, you connect it like clock and all. Then you can leave the rest of the wires to be automatically routed by the software, auto routing software. Then after that you can fill the entire PCB with ground plane. So if I use this rat's net after drawing the polygon, now you can see my entire remaining space will be filled with the ground plane. So this is now my ground. If I highlight this now, so this entire area is filled with the ground wherever the space is left, which is a copper material. So this is, in short, is a perfect PCB design, so that it's not only just working, but it should be reliably working. So far we have seen how to design the circuit diagram and how to design the layout and to create the Gerber files which are used while making the PCB. Now let us see how to design a component and its footprint, so that if the software doesn't have, then one can create your own component by using this software. So go to file. When we say this time, I will just close this project. So when I say go to file, new, this time instead of schematic diagram or board, I want to go for library, where I want to create a new component. So again, this is the workspace for creating the component. So creating a component is 3 steps. First, symbol. Second, package. Third is device. So one has to follow all these 3 steps to create a component of your own, which can be used while designing the circuit diagram and layout. So let us go for symbol. So the symbol, since you want to create a new symbol, give the name of the symbol. Say for example, 456 is the IC I want to create. Say IC 456. Say OK. So create a symbol. Yes. Okay. Now as you can see, again the grid is open. You can again adjust the grid, whatever is the size of the grid, alternate grid. The do you want dots or you doesn't want lines? What is the distance between the grids? So all these things can be user can set. Now you want to design a schematic diagram of a component. So here dimensions doesn't matter, only how it should looks like when you draw the circuit diagram is the point. So as you can see, left side you have the wire to draw the symbol of the component which you want to create. So when you draw the symbol, so again as you can see in which color symbols, like we are using the symbols layer, you want to use. If you want any inclination, you can use the inclination whenever you change the side. So this is what you want. You feel like the symbol of the new component should looks like. You can change the width of the line, but it doesn't make any difference. Similarly, you can also give the description of your symbol. Okay. So then how many pins this package you are creating, the new component which you are creating. So this is the pins. For example, if I select the pins, the moment I selected the pins, see what are the types of pins which are available. Some of them are, you can see, with a notch, right? You can use, say for example, I want this pin, second pin, say third pin, and fourth pin. I will put one more pin, let us say fifth pin. So this is my representation of the IC, where my IC has 5 pins. So if you want to change the names, you can change the name of the pins. At present, the name is P$1. So if you want to give the names, right, the functionality wise, I will say for example, uh, P1. I will say for example, IO. So now the name is different. Now similarly, I will say P2. I will say, for example, VCC. Now pin 3, I want, say, ground. Pin 4, I want, let us say, clock. Pin 5, I want, let us say, read, write. Okay. So now, so if you take this symbol into your circuit diagram, this is how it looks like. A new package you want to create. So you can again modify the things, move the things, delete it. So all edit options are there. If you want to give any text to this package, then you can give the text, say IC 456, like that. So where you want to place it. So like that you can, at least the appearance point of view, whatever the way you want, you can represent your symbol of the component which you are interested. Now you can save your the symbol. So now when you say save, look at that. It is saying the extension is LBR, because you want to create a new library. See, is by default it is asked for the library, and the path also is fixed. It is always in program files eagle folder. LBR is the library where you will have to save always. Whenever you either create a library or you download from internet, then you can always place that in LBR folder, so that by default the software will look from there. So I will give the library name as, say for example, YSR is the name of the library. So now, as you can see on the top of the screen, this component library is called YSR LBR. IC456 symbol is saved into that. So any description about the IC, that is functionality of the IC, say for example PLL or something, if you want to create, so then you can give the description, so that whenever you view the IC, then the functionality of the IC you can see in the description. So this completes of creation of a symbol for a component, a new component which you are interested. Now the second step of the creation of the component is the package. You'll have to create a package. So now give the package name. Package names are usually what we have seen in the data sheet, like PLCC package or a DIP package or uh, SOIC package. So you, whatever is the standard packages are there, you have to design, create those packages. I will give some name called SOIC dash 5 because it has 5 pins, so the dash 5 indicates the number of pins. So new package I want to create, say okay. So it says that do you want to create, yes. Now again the workspace is created where left side, if you see this time, these are all the pads which can represent. Now you should be very careful while designing the package, is because the dimensions matters, because that is how it looks like. Say for example, if you see the packages where you can see the distance between the pins and the thickness of the pad, size of the IC, number of pins of the IC, pin number 1 of the IC, all of them matters. So it should physically, it should be same. There should not be even a fractional difference in terms of functionality or in terms of placement, in terms of thickness, in terms of the distance between the pins. It should not differ. So completely the package you have to design after downloading the data sheet of that particular product. So looking at the dimensions, then you go to the software. Now now for example, if your component is a surface mounted device, then you will have to select the pads of surface mounted. If it is a DIP package, where in DIP package you can see there are pins are there where you will have to insert them. So that means the package you will have to choose is a pad which has a hole. So SMD doesn't have hole. Say for example, let us design a package which is surface mounted. So whenever I am moving the cursor, now see the displacement, how much displacement it is doing. So that depends on again view grid. So what is the distance between one grid to other grid is indicated by this. If you want to reduce the grid size, for example, right now 0.05 is the grid size. I will reduce by another fraction. So alternate grid I am reducing by another fraction, half of it. So if I say okay, now you will surprised to see that now the distance between the grids is further reduced. So that is how minutely also whatever is the distance between the grids, you can adjust by selecting the proper units and proper size. So now see, if the cursor is, you can see in fractional of two fractions of a inch, this is moving. So now as per the data sheet, now you need to decide what is the distance between the pads. Accordingly, look at the your axis points, x-axis and y-axis. Accordingly, place the pads. So as per now, after looking at this, I am just putting as if the component looks like this. So you should be very careful while choosing the pads. So when you when you take the printout of this, then if you place the component, then it should 100% match. So there should not be any difference in terms of package and placement of the component. So even if you want to draw a outer line of your package, say instead of top, you can choose some outer line. Say for example, I will choose some values, t names. Okay, so some shape, if you want to give it, you can always give it for your based on the size of your component. You can do that. So this doesn't have any significance, just to leave that much space so that one can understand that the size of the IC, at least this much space you should leave. But otherwise, what is important is look at the width of the pad, length of the pad, distance between the pad, distance between the left and right, the top and bottom. So this matters a lot, which is exactly as per the dimensions, mechanical dimensions of the data sheet, which is represent which you are interested in that. So once this is done, even if you want to have any minute adjustments after taking the printout, you can always do it by saying move command. You can move your pads because these are you have designed these pads. So I always suggest take the printout of this first and the place the component and accordingly adjust where what is the actual size of that, because this is once for all we do it, every time we don't it. And if you want to give any names to that, you can always give to the pads any name for that. Right now the pads are P3, but pads there is no meaning because we don't draw the lines on the layout side. Usually we join the lines on the top side. You can also delete whenever you want anything because we only created, or undo command you can use it. So t again to do whatever we want, and you can use text box to give some name, and you can also give description about the package. Say for example this is about the package, so you can say SO SOIC. So like that you can give some description so that whenever you select the package it will indicate what type of component is. And you can always have that copy command, move command, and change any of this width and all that without deleting and redoing the things. So this completes the second step of creating the package or footprint of the component. Now while doing that, I repeat again, the placement is very important. You should know which is pin number 1, which is pin number 2, 3, 4 and 5. The orientation is important, starting point is important, distance is important, width and length is important. And whether this IC is a SMD IC or it is a DIP. In DIP, the pads will be like this. The pad, you can use a square pad or a round pad or a oval type, whatever. So there is a difference. If you see, the difference is this pad doesn't have hole, which is a surface mounted device where you have to solder on top side. But this green means this pad will appear on top side, also will appear on the bottom side, and there is a hole so that you can insert the component to this. So depends on the package and depending on the pad, you will have to design your footprint. Okay, now let us save this package where we are interested in. So save it. Now it will save into the same library. If you remember, we have designed already schematic and now symbol. We have designed now the package. Now let us go to the third step, that is which pin is what function it has. Not necessary that this is pin number 1. This can be pin number 1. This can be pin number 1. Like that, we have to assign the pin functionality and the pads. So the third step is device. When you go to the device, now it is asking what is the name of the device. So the device is, let us say, some PLL. I will give some name, PLL or some 456, just some name. You can say OK. So it will create. So now there are 3 windows are there. So 3 windows is, first you will have to import. You go to add, it's like a library, add to that. You have created a symbol name called IC456. If you say OK, now exactly the center of the screen, place the symbol. So that's what is, this is your library. By using add function, place the symbol which you have designed. Okay, cancel. Okay, now this completes the selection of the symbol. Though now the next step is, now you want to add the package. So you can go to new. So when you say new, then from that library, whatever is the packages are available, it is showing. So I am right now we have designed only one package, that is SOI5. You can say OK. So now you can see on the top of the screen the package is added. So left side you have the symbol and right side top you have the package. Now right side on the bottom portion, now you will have to assign the pins. That means which pin belongs to which pad. For example, this pin, not necessarily this pad, it could be this also, it could be this also. So that is what you will have to add. That is, when you say you can see there is a exclamation is there. That means you have not assigned the pins to the pads. Okay, so now you will have to connect the pins to the pads. So in order to connect the pins to the pads, you just double click on this. Then it will open the window where one side it is showing the functionality of the pin, other side it is showing the pads. So if you are interested in connecting the first pin to the first pad, then select both of them and you say connected. Then you can see on the right side the first pin is assigned to first pad, but in second pin you want to connect it to the second pad, then select that. Otherwise, if you want to connect third pad, now you see you are going to connect the second pin to the third pad. If you say okay, sorry, connect it. Now you can see second pin is connected to the third pad. So like that, whichever is the, if you want to redo that, then you say disconnect it, again it will come back to the original state. So that is how you must finish all the pins to the all the pads, and you can say okay. So that completes, as you can see, that completes the connectivity of a pin to the corresponding pad. If you want to again give any description about that package, you can do that. Otherwise, you can save the your new device. So this completes design of a new component and new package. The Once you have done this, let's close this. Now if you go for again file, new, schematic diagram. Now I want to take that component where I have newly designed. But then since this is first time we have created, you'll have to say library, then you will have to say open wherever that you have created. So your library name is called YSR LBR, newly created, say open. Right? So this is ready for either to edit, or else if you want to use it, go to library and say just say use command. So LBR open. Okay, now since you said use it, then it is available on the left side. That is, you can go to the add facility, then the same library added to the existing libraries. So that is, you can say YSR. So in this YSR, if you expand this, then a new component is added. So if you select it, you can see it shows the symbol, it shows the package, and its a description is available here. If you bring it to your workspace, now whatever is the symbol you have created is there. And if you go to the board side, if you say yes, now you can see in your workspace you can move the component which you have newly created. Okay, so it is always better to place on the center, so that this plus symbol should be here. Okay, so now let me draw some lines by connecting some more component, so that you will see how to do the layout. Let me take some gates. Okay, so just I want to, so you can join your IC to the existing circuit, and you can finish your circuit diagram. So now this joining components, same technique what we have explained earlier, where you can complete the routing part. While doing this, let us say I was telling about how to take the printout. Now this component, right? If you see the dimensions, so how to take the printout? Go to file, in print command, you can first of all you can say where that has to be printed. It is there on the alignment on bottom center, or where you want to take the while taking the printout. But most importantly, while taking the printout, do not change the uh, scale. This is what is very very important. Scale should be always 1, so that when you take the printout, it should be 1:1 printout. That means exact dimensions printout we want, so that when you place the component, 1:1 matching should be there. So this is one method of designing your own component, your own package, and then taking them into your circuit. Second is, for example, I was telling about, you want to open existing library. Say for example, I have some 74 series library is there, so I want to open that. So in this, now now this time what we are doing is, instead of creating a new component, I want to open a existing library, existing component, and then I want to modify that. So that instead of doing everything, just simply some names I want to change, or I want to add one or two pads or pins extra, so that as it is I can use it, so that it doesn't make any difference for me as far as the uh, either package or functionality is concerned. Just a few changes I want to have. So then the whole procedure is same. That is, when I'm saying, already I said, I have this time I have opened a existing library. So I can, since the library is already opened, so simply I will have to go to the symbol. Now you can see the existing from the library, it is showing what are the symbols are available. For example, 7400 symbol I can open. So now you can see complete that symbol, you don't need to redesign. It is already there. So any modifications if you want, say for example, if I want to move this pin, something of that type, you can always do that. I mean, any changes you want. Then you can say save. Say for example, I will place it, say for example like this. Okay. So now when you say save it, then so then you create a backup file and save it. So similarly, if I want to change the, for example, so many footprints are there. For example, I will take DIL 14. So when I open this, now this is the how the IC already existing library looks like. If you want to make any changes in this, then all these tools are available. You can make the changes and save it. Then now you can go to again the third step, that is the device, and okay. Now you can see left side all the packages and their symbols are available. Now, do you want to make any changes into this? Now you are free to change the pin and their corresponding pad. So there are two methods. One is either create completely your own symbol, your own package, and assign the pins. Second, open the existing library, existing component, existing package, make some changes into it, accordingly assign it and save it, so that as it is, it's there, just few changes you can do it, and you start using in the main circuit diagram. Okay, so this is how one can create new symbol into the library. Otherwise, if some libraries are there on the internet, let's say for example, you can go to the website called CADSoft USA, where this Eagle software, either you can download it or purchase it. In this, you can see downloads, whether you can download the Eagle software, where Windows version is there, Linux version is there, Mac version is there. The free software evolution version is available, or else you can download the libraries. So libraries means several universities and students have contributed. Hundreds and thousands of libraries are available. So even by any chance the software doesn't have these libraries, from here you can download it. But what is important is, say for example, you want to download this library. So when you download this, so this, after downloading, where you should save it? You should save it always in the in your C directory, in program files, and in Eagle package you can see LBR folder. So In this is the path always, so that for example PTS 525 I am saving here. So it is already there, but you can say save it there. So once you save it there in that uh, folder, then you can always library, then you can say use, so it will recognize that path, and from there it, so that it will be easy for you to remember where the libraries are saved. So this is how either one can create or one can uh, download from the internet the new libraries and new components, so that in future as and when you required some new component is released in the market, without any hesitation you can create your own component into the software.